Hello and welcome back to another mathematics episode. Today we're talking about logistic regression. If you haven't watched the video about linear regression, it might be useful to do that now, as it might be easier to understand logistic regression if you've understood linear regression. So, as said in the previous video, linear regression models are widely used and often they are appropriate for modeling, for example, medical relationships, but they cannot be used for binary events like mortality or the development of a disease versus not developing this disease. So we don't want to predict values based on observed data, but we want to predict the probability of one or the other event. So on the y-axis, we've got basically just 0 and 1. Logistic regression is modeled as the log odds function of the linear regression. The log odds are also called logit. The odds, now we have to talk about odds first. So here you can see the mathematical definition of odds, and it's actually just a change of something happening versus not happening. And the log odds is used instead of the probability because probability only can have values between 0 and 1. And the odds can take every positive value. That's what we want for logistic regression. Here you can see the equation. And if we're now taking the exponent of beta, we've got the odds ratio. So the interpretation of the values that we get from logistic regression is basically the same as for the relative risk. So if we've got an odds ratio about 1, we've got a positive association between the exposition and the disease. For example, if someone is smoking, so he or she exposes himself, he or she is more likely to get lung cancer. On average, of course. An odds ratio smaller than 1 means that there's a negative association. For example, if someone has high HDL levels, he or she is less likely to get a heart attack. And odds ratio 1 means no association. We've got two main differences between linear and logistic regression. So the first one, we've already talked about that, is that y now is the probability of the outcome. So we've just got two categories, and no, in linear regression we've got two continuous variables. Secondly, now we've got an e function. And the values, so because of the e function, the values are on a logit scale. And this is necessary as we need this binary outcome, so that the values really just take 0 and 1. As you can see in the drawing, if you just have a line, the values can be below 0 or above 1. And this is not what we want. And we form this line via the maximum likelihood estimation, and that, as the name suggests, is the model that is most likely to detect the observed outcome. Again, we've got 4 assumptions that have to be fulfilled in order to create a stable model. The first one, similar to what we've observed or what we've said in linear regression, is that the errors should be independent of each other. So repeated measures or also multi-center studies violate this assumption, and we have to adjust for it. The logit function for the continuous independent variable has to be linear, and a linear relationship between the variable and the logit transform outcome is required. If this assumption is violated, we can do another scale for transformation, but this won't be described in detail here. The third assumption is that the independent variables they shouldn't be highly correlated or even redundant. For example, we shouldn't include BMI and weight. This would lead to very high standard errors concerning the beta coefficient, and that's definitely not what we want. The fourth assumption is that we should not include highly influential points, so-called outliers. Here you can see what an outlier does. So just by including this blue point, the whole curve makes a shift to the left. And if you've got significant outliers, it might be reasonable to check if this is a measurement error or something else, or more generally speaking, just a reasonable and scientifically correct reason to maybe say that this point is an error. So this topic was rather complex and there is a lot of mathematics behind it. This was just a very, very basic introduction so that you know the basic differences between linear and logistic regression and some assumptions and when to use logistic regression. I hope you enjoyed this video. See you in the next one.